Good afternoon. My name is Timeyer Hayter. I am in Module 5, Assignment 5.1, and we're going to start off this assignment by reviewing the instructions. So here's the data set that we're going to be utilizing, which is the coaching instruction data set. And then our video should include a paired t-test. We're going to state our research question and hypothesis, run an analysis. We're going to interpret the output. We're going to calculate the percent change between the data set. We're going to state our conclusion in APA style, and then we're going to discuss whether the differences are meaningful in a real world experience. Okay? All right, so we know what we need for the assignment. Let's go ahead and go to our data. All right, so here's our data set right here. All right, now that we're going to get started, let me go back on this. All right, there we go. Okay, so our research question: is there a significant difference between bowling scores in game one, which that is pre-instruction, before the coach assists them with any coaching tips, versus their post-instruction scores? So is there a significant difference between game one scores and game two scores? And the main point is going to be the coaching difference between that two, going from game one to game two. Our null hypothesis is going to be there is no significant difference in bowling scores between game one and game two. And then our alternative hypothesis is there is a significant difference in bowling scores between game one and game two. Okay, now that we have all that taken care of, we're going to go to analyze. We're going to go to compare means and proportions, and then we're going to go to paired sample t-test. Okay, so for game one, I'm going to click on that. We want this to be for variable one, and then game two for variable two. And as you can see down here, I already have standard deviation of the difference selected, and we're going to click OK. Let's see what that comes up with. All right, so here's our breakdown of the data. So we're going to start off up here with the paired samples statistics. So game one, so our M value, our mean is 90. So that's overall score. Our N value for both game one and game two is 20. So we had 20 participants for game one and game two. And then our standard deviation for game one is 13.541. Okay? So as I stated earlier, M value for game two is still 20. But we see the average or the mean go from 90 to a 94.95. So nearly 5 points. Nearly a 5-point jump in that. And then our standard deviation for game two is a 14.318. Okay, so just from the paired sample statistics, we can see a difference in that score. So remember, game one is pre-instruction, and then after game one, the coach gave them a 15-minute coaching tips, basically, and then they were to perform in game two. And as we can see, we have nearly a 5-point difference. So specifically 4.95 difference. All right, now we're going to go to the paired samples correlation. So for game one and game two, we have an N value of 20 with a correlation of 0.556. Okay, so the correlation of 0.556. So a small to weak correlation is a 0.1 to a 0.3. And medium is going to be 0.3 to 0.5, and then large is going to be 0.5 and up. So since this is over 0.5, that is a large and or strong correlation between the two games. All right, so we know that our correlation between game one and game two is significant. And then speaking of significance, we're going to go to our significance values and our p-values here. Okay, so our one-sided P is 0.005, and then our two-sided P is 0.1. So looking at both of those, they're both less than 0.05. So both of those are less than 0.05. So that means that the data set is statistically significant comparing those two. Okay? All right, so now we're going to go down to our paired samples t-test. So here's the difference between the 2 points in terms of average. So it's basically our average score difference. So basically 4.95 difference. Okay, and then it has our standard error mean. Here's our t-value, 1.685, and then our f value is a 19, and then here's our significant values on this. And once you pair them with a 0.054 for the one-sided, and then two-sided is 0.108. Now, if you're looking at the paired samples test significance and/or p-value, both of those are greater than 0.0. Both of those are greater than 0.05. All right, so that's basically saying it is not statistically significant based off the paired samples test. So we kind of see we do see a difference between those two. So let's go down to our paired samples effect size. So how is our data set affected? So pair 1, gain 1 and 2, Cohen's D. Our standardizer is 13.137, and our point estimate is 0.377. Okay, 0.377. All right, so small is 0.2. A medium for Cohen's D is a 0.5, and then anything over 0.8 is a large. It is a large category. So 0.377 is going to be small to moderate in terms of that scaled score. Okay, so looking at that, we can see that there is some statistical differences between the two. And just by looking at the data, since we're talking about sports, and instruction, in my opinion at least, is important when it comes to progress, when it comes to performance. So even though it's only a nearly 5-point average, 4.95 difference in the mean, when it comes to sports or anything that has a scaled score, that can be a big deal. That can be the difference between winning and losing. That can be the difference between making the team and not making the team. That can be the difference between winning a championship and losing a championship. Okay, so that is a big difference. That can be a difference between making the league team or not making the league team. So it doesn't seem like it's a huge number, 4.95. But being that I have a sport background as a former player, the more points the better. So even though it's not a big margin in the sports world, that's a pretty big deal. Okay. All right, so we're going to calculate our percent change. So I should already have my calculator up. All right, so the percent change is going to be the post score minus the pre-score divided by the pre-score, and then times 100. So we can go back up to the top. Post score is 90, so it's going to do 90, 90. Well, I'm sorry. It needs to be post minus pre, so it should be 94.95 minus 4.95. Let me make sure I did that. So 94.95 minus 90. Okay. And then we're going to divide that by the pre, which is 90. Okay, so we get 0.055, and then we're going to multiply that number times 100. All right, so I just gave you the breakdown of the change in percent, the percent change formula. So I broke that down, and our calculations after doing the post minus the pre, and then divide that by the pre, and then times it by 100, we get a score of 5.5. Okay, so going into our conclusion, it says a paired sample t-test was conducted to compare bowling scores before and after receiving coaching instruction and coaching tips. Okay, there was a statistically significant difference between pre-instruction scores, which was a 90 for the mean. Our standard deviation was 13.541, and our post-instruction scores, which was a 94.95 with a standard deviation of 14.318. Okay, and then we already discussed our practical interpretation of that, which is, although there is a 4.95 difference in average between the scores, that can be the difference between winning and losing. That can be the difference between making a team and not making a team. And that can cost you a championship. So, in my opinion, outside of the statistical difference, I personally think that is a big difference in the sports world. So I hope that answered all of the questions that was required of us today. I'm pretty sure it did. And that's all for me today. So thank you for your time.